So in the last video, we looked at the standard normal distribution curve and talked about the empirical rule a little bit. And with the empirical rule, that was the 68, 95, 99.7. That was giving us the area under the curve between -1 and 1, that was 68%. Between -2 and 2 was 95%. Between -3 and 3 was 99.7%. Well, we want to also be able to find the area under our standard normal curve in other places, not just 1, 2, and 3 standard deviations. So the way we're going to do this, we can use the table E in Appendix A of our textbook, or we can use technology to find the shaded area. And since the book goes through using the table of values and such, I'm going to try to teach you using the calculator. So with our technology, the command that's mentioned here is the normal CDF. Okay, so this is our command line that we want to look for. So to get to normal CDF, now normal stands for normal distribution curve. Well, on our calculator, if you look at the third row down, the bars key, it's right beside a clear. Right above that in blue, it says DISTR. That stands for distributions. So we're going to press second bars, and that brings up all these different distributions that the calculator will work with. Now, we're only going to be focusing in our class with the normal distribution. So we don't want to use the first command, though, normal PDF, because what normal PDF gives us is the height of a curve at a particular value. We're not concerned about height. We want to find area, shaded areas. So we're going to go down to choice 2, normal CDF. That stands for normal cumulative density function. And in this, when we hit enter on normal CDF, notice, I should clear that out. Let me clear out my stuff here. Notice here that in our command line, back over here on the PowerPoint, it says we're going to use normal CDF. We need to type in a lower bound, an upper bound, and separate these things with commas, a mean, and a standard deviation. So back over here to our calculator, if I considered a problem, like this first one that's given to us, it says the area under the standard normal distribution curve to the left of a z value. And they talk about using the table, but we're going to use our calculator. So the area to the left of z equals 1.3. Now, I've already got a little sketch of a normal distribution curve, so we're going to say that this mean is 0, since this is standard normal. This standard deviation is 1, so we're going to mark off 3 standard deviations to the right and 3 to the left. So that's -1, -2, and -3. And what it's asking me to do is find the area to the left of z equals 1.32. So I've got to estimate 1.32 is somewhere along in here. So I'm looking at the area to the left of that. So what I'm considering is all of this. What percent of the curve the area would be to the left of 1.32. But that doesn't fit our 68, 95, 99.7 rule, but we can use this command. So our command looks like this, normal CDF, and our low bound. Well, when I think about this curve, it goes infinitely here to the left, and I'm looking at all these numbers out here to the left. So I could choose something like -1 million or -10 million. But, usually we just choose a small number. It doesn't have to be outrageously small. So I'm going to use for my low bound a -1,000. And then it's shaded, shaded, shaded until I get over here to the upper bound, and the upper bound is sitting at that 1.32. And the mean, since this is a standard normal curve, is equal to 0, and the standard deviation is equal to 1. So I want to type that into my calculator. Now, some of you don't see this screen coming up. All you see is normal CDF in a parentheses, so you type in these 4 numbers separated by commas. Remember now, the comma key is over here right above the number 7. So we're going to type in our numbers here, negative 1,000 for our low bound, and our upper bound is 1.32, and our mean is 0, and that's already there, and our standard deviation is 1. So now at this screen, all of our screens should be looking the same. Normal CDF, negative 1,000, 1.32, 0, and 1 separated by commas. So when we key in enter, it gives us the area under the curve to the left of that, which in this problem is 0.90. I'm going to round off 4 places, 66. And I just do that because your book usually rounds these off to 4 decimal places. So let's take the second one. Here we want to find the area to the right of negative 0.67. So I'm just going to estimating here where my 0, negative 1, negative 2, negative 3, and our 1, 2, and 3 are. And I'm looking to the right of negative 0.67. So I'm going to kind of sketch that in here. And this is the area I want. So when I get ready to type in my command, the normal CDF, what is my low bound this time? Well, as I'm reading from left to right, my low bound starts right here at negative 0.67. And then it keeps shading forever to the right. So we just choose some big number, like 1,000 will work. And then our mean is 0, and our standard deviation is 1, because this is standard normal. So let's do this in our calculator. So go back to second vars, bring up our normal CDF command, choice 2. My low bound is negative 0.67. And my upper bound is 1,000. And my mean and standard deviation are still 0 and 1. And I'm going to key in enter on paste. And that's all of our command lines look like that. And this answer is 0.7486. But you know, when you think about these answers, they kind of make sense, because if I started at 0 and went to the right, that's 50%. So I know, since I'm starting here at negative 0.67 and going to the right, it's got to be more than 50% of the area. And our last one here on this slide is between 1.45. So here again, let's mark these off. 1, 2, and 3. So 1.45, just kind of estimating there, and 2.32. And what I want to do is find this area in between. Now, if you had to estimate, is this area going to be less than 50% or greater than 50%? Of course, it's less than 50%. Okay, so we're going to use normal CDF as our command. And our low bound is at 1.45, because that's the first place we see something shaded. Nothing shaded, nothing, nothing, and then it starts here. It stops at 2.32, and our mean is 0, and standard deviation is 1. And we're going to type that into our calculator. Second vars, choice 2, 1.45, and 2.32, using 0 and 1, and enter. And our answer for this one Looks like it is 0.06, excuse me, 3, 4. I'm having to write on something that I can't even look at. 0.0634 is our solution for that one. Okay. So moving on, I've got 4 problems here that I'd like for you to do. Okay, so I'm gonna pause the video for a moment, and I'd like for you to do the same. Pause the video. You set up your commands and draw your sketch, and then find the final solution. Okay?